This is a lesson in the types of organic molecules. There are 9. Hydrocarbons, alcohols, aldehydes, esters, amine, halides, ethers. We're going to begin with hydrocarbons. The simple organic molecule. So hydrocarbons we're going to split into 3 subgroups: alkanes, alkene, alkyne. So alkane you will identify because the C's will only exhibit single bonding. The bond between the C's and alkene will exhibit double bonding, and alkyne you'll get a triple bond. One of the important things about naming hydrocarbons is the prefixes. So we need to know how many carbons. So meth indicates 1, eth, prop, bute, pent, hex, hept. So let's use bute for an example. Okay, so bute indicates those 1, 2, 3, 4 carbons in the longest chain. So let's make that 1, 2, 3, 4 carbons. And if there are only single bonds between the carbons, we assume hydrogens are hanging off. 3 hydrogens here, 2 here, 2 here, 3 here, and we would nickname this, or we would name this butane. If, however, we had butane, but we noticed there were double bonds, we'd call it butene. And if there was any triple bonding, we would call it butene. Now, let's take butane for example. If butane was going to become a functional group, we would call an alkyl group. It would lose an H. So instead of butane being C2H10, we would remove an H, 1 H, and it would be C2H9. And what that would do, it would allow it to, this would be butane, this would be butyl group. And so this would be CC, oops, excuse me, butane, bute is 4. Pardon me. So you would double the 4 and add 2 for 10. If it was butane, you would double the 4, add 2 and subtract 1 for butyl group. So when we put them together, there would be room, there would be 1 less H on the end here, and there'd be room for functional group. All right, so here's the alcohol. So alcohols are identified by a C bonded to an O bonded to an H, COH. And so just simply put, if we wanted 4 carbons again, the alcohol would be identified by the OH bonded to the C. That would be the functional group, and then maybe we even have a methyl group attached as well. And so how would you name this? Well, we would look and we'd say, okay, well, we have 4 carbons and an OH, so that means it's going to end in OL. And so it's going to be 1, 2, 3, 4 butanol. but I also noticed that there's a methyl group here. Which is it on? 1, 2, 3, or 1, 2? Well, 2 is closest, and so we're going to say it's 2-methyl butanol. Important things about an aldehyde. The functional group for an aldehyde I like to call CHO. They're going to end not in OL, but AL. And the functional group will look like this. So that will be the functional group. And so it's always nice to start with the functional group. So if you have the name of the molecule, 2-methyl pentanol. Okay, you see it ends in AL. So because it ends in AL, it is an aldehyde. You write that functional group, C, double bond O, H. So I know it's an aldehyde. And then I got to figure out what's attached. Okay, so we need a total of 5 carbon chains. We need one chain of 5 carbons. 1, 2, 3, 4, 5. And on that parent chain we have a substituent, and in this case it happens to be a methyl group at position 2. That's aldehydes. Esters. Okay, so esters end in 8. And they have AC, double bond O with an O. So it's a Cu group, I like to call it. A Cu. Cu group. So something's going to bond to that C over here, and that O is going to also bond. So let's figure out what that is. All right, well, let's compare methyl propanoate with ethyl propanoate. ATE means it's an ester. So let's draw that functional group. Let's draw it for the first one first. So we've got C, double bond O, O. And here we have C, double bond O. Oh, they're going to have the same functional group. Okay, so now we've got to see how many C's are connected to that carbon chain. And it is prop, so there's 3. So 1, 2, 3. That's the longest chain of carbons. And this methyl in front of this carbon chain tells me that there is a methyl group, CH3, attached to the O on the other side. So it is methyl propanoate. That is the ester. For ethyl propanoate, we would still have a chain of 1, 2, 3, 1, 2, 3 C's, but instead of having the methyl group as our alkyl group attached here, we'd have an ethyl group, CH2, CH3. Okay? And that would be our ethyl group. Amine. So the functional group for amines are the variable group connected to NH. Okay? So the NH really defines this as being the amine group, and the name the suffix will be amine. Okay, so let's take a look at methylamine, for example. Okay, so we have methylamine. So we have an amine group. And H. We have a methyl group hanging off of it. Or we could just write it NH. So that N needs to bond with one more thing, so it's actually going to be NH2. So it would be NH2 with an R hanging off it. And in this case, the R, or the variable group, is methyl. So you just write CH3 hanging off it. So that would be an amine group, where you look for that NH or NH2 group, and you look for the word amine. So we've got a methyl group attached to an amine functional group. Halides. The H is replaced by halogen. So they are in the C chains just like the alkyl group, so to speak. So halides are on the C chains. They attach to the C chains or rings like an alkyl group. And we defined that as being example. So if we have a chain, this could be methyl, that could be ethyl, but this would be the alkyl group. Okay. But in this case, the H is replaced by a halogen. So the H is replaced by halogen instead of a methyl group or instead of an ethyl group. And these halogens include F, Cl, Br, and I. So if you notice one of these hanging off the chain of C's, or the ring of C's, then this is a halide group. So let's name one. So if we have, let's see, 5 C's, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and we notice that we have an F hanging off here, or an F hanging off here. Okay, then we would call that 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have pent. It ends in ane. So we'd have pentane. We have 2 groups. So we indicate that by the prefix di. So we have di and then flora. And I want to know where these 2 fluorohalogen functional groups are. Well, they're on 1, 2, and 3rd carbon. So we end up with a 2,3-difluoropentane would be our halide group. And last but not least, our ethers. So our ethers are most notably defined by an O with 2 functional groups hanging off it. Okay, so that R that I use is variable. Okay, so for an example, it could be a methyl, like CH3. It could be ethyl, right? CH3, CH2, could be one of those ethyls. So it can be variable. That's what the R stands for. So let's take ethyl propyl ether. So just like an amine, the word ether, or just like a carboxylic acid, the word acid appears in the name. So we've got ethyl propyl ether. Since it's an ether, we just draw that O with 2 bonds, and then we try to figure out what's attached. Okay? So this is just written in alphabetical order. It doesn't matter which end you put the ethyl or the propyl group, but nonetheless you're going to add the alkyl groups because it's YL and YL, they're alkyl groups. So you can add them like this. CH2, CH3. So this would be ethyl because it has 2 C's. And then over here you would just add 1 C attached to 3 H's. So this would be the ethyl group, and that would be the propyl group, and they're attached to oxygen, an O. That's how you define an ether. So there you have it. Those are your 9 types of organic molecules.